Welcome back to all of you. Now let us begin with the discussion we did. So till 6 point we discussed, and we discussed the image formation by a plane mirror, by a concave. Now let us see the convex part. This is the ray, and the second part we are going to talk about, that is of the convex mirror. We have this, and what are the possible conditions to put the object in front of a in front of a convex mirror? Any one of you? This is the pole, right? Where is the center of curvature? Wherever it completes the sphere will be the center of curvature. So it completes the sphere this side. So we will be having the center of curvature in this location, not in this location. Okay. Reason I told you, focus is here. Okay, fine. Now if I wanted to put my object always toward the left side, because we will put the object always in front of the reflecting surface only. So in front of a reflecting surface, if we put the object, it doesn't mean we are putting the object right or left. It matters we should put our object in front of the reflecting surface, because then only it is possible to get the reflected rays. Now the infinity we have, and after that we have between infinity and pole, and then pole is there. So how many possible conditions are there to put an object? Let us figure it out. So at one number object is placed, and then 2 number the object is placed. Yes or no? Clear? We don't have the third, because only 2 possible conditions are there. Rather than that, we cannot put the object. Okay, so 1 dash, we are getting 1. It means virtual image. And I have put the image above the principal axis as the object is. It means it is erect, not inverted. If it would be inverted, I would have put this way. Clear? Okay.
Yes.
Second, 2 dash between P and F. Let us draw the diagram. This is the convex mirror we have. Principal axis passing through the pole, which is half of the effective length of the mirror. The object is at infinity. It means the parallel incidents are coming, right? Suppose this is the 1 number, this is the 2 number. So what we found is, this is the point of incident, and at the point of incident, what we have to draw? We have to draw the normal. So when we draw the normal, it always intersects to the center of curvature. We very well know. Yes or no? So this is the center of curvature we have. How much is the incident angle? This is the incident angle, right? Angle of incident. This is the angle normal, again from the normal this direction, and we will get the reflected ray this way. Now this is the 1 dash. Now I will not draw this normal. I will directly draw the path traced. This is more diverged. Yes or no? Incident and reflected. the path, the angle made by the incident ray and the reflected ray, that total angle is actually the divergent angle of divergency or divergency of the ray. Now, if I talk about the second ray, which is near to the principal axis, and if I draw it, what I found the interesting thing is, it would be having lesser angle of incidence, as you all can see. Clear? So this would be having a lesser divergent because angle this and this has to be equal, and this is what the reflected ray you are getting as 2 dash. Again, this is the third ray. You will get 3 dash, which will be having more or less, which will have least divergency. Again, the fourth ray, and the ray fourth is at principal axis. You will get the no divergency, and you will get the divergency as 180-degree angle, because incident and reflected, they both are in opposite directions. Getting 180-degree, 0-degree and 180-degree, you all are confused. I know many of the students are confused when to take an angle 0-degree and when to take an angle 180-degree. That I'll let you know in the numerical part when it will come, don't worry. So what the interesting thing we found is, the far we are from the principal axis, the more is the divergence, because of the angles are more. Okay, so what we are getting the pattern 1 2 3 4 1 2 3 4 in dash, we are getting the values. Now if we reduce it back, what we found, all the rays are intersecting at the half of the distance from the PC, that is FP, which is half of the radius of curvature, that is focal length. Why half? Because we proved from the similar triangles. Okay, so this is what we have, focus. So all the incident parallel in front of a convex mirror always intersects at the focus, and we are getting the image 1 dash, as you all can see. Okay, now if I talk about 2 dash, let us redraw the diagram of that as well. You will come to know. Suppose this is the object, incident ray, point of incident. Clear? Now we very well know center of curvature, and we will draw the normal intersect at the center of curvature. Now this is the angle of incident, angle of reflection, equal angle, the reflected ray reduced back. What we are getting, this is the focus. Okay, right. Now we take another ray, ray 2, which intersect at the pole, and this is the angle of incidence, angle of reflection. This is what we are getting, 2 dash of the incident ray 2. Again, we produce it back. What we found, where it intersect, at this point it intersect. The 2, this is 1 dash and this is 2 dash, virtually produced. So always remember the rule, either a real reflected rays both should be there and they will be intersecting, or both are virtual and both virtual will only reflect. This is the law. Means you cannot take one real ray and one reflected ray intersecting. No, this is not the law. Okay, so if you're taking virtual produced, so the second should be virtually produced ray and they both should intersect. Okay, because we have one of the example of makeup man only. You can see in this example, this is the incident ray 1, and 1 dash is going this way. This is 1 dash, yes or no? And on the same side we can see this is incident ray 2, which you can see intersect here. This is a 2, this is the incident ray, and this is the reflected ray. So incident and reflected cannot be considered. They are actually not intersecting. We are seeing on the one vision, two-dimensional screen, we are drawing the diagrams and all. So we see that they are intersecting, but it is not actually intersecting. Okay. So 2 is an incident ray and 1 dash is a reflected ray. They both are not cutting, they are aparted and then they are moving. Okay. So reflected and reflected should cut itself. So 1 dash, this is the 1 dash produced, and this is the 2 dash produced. This is a 2 only, which is incident ray. Is it clear to everyone? This you have to remember. So incident and a reflected pair, virtual pair. So this is what we are getting the image, and the image is diminished. This is one of the example of your automobile. You are seeing that a big bus is visualized to you, and a very small vision you can see. Now let us see the range of vision. If I draw the normal here, you will get 90-degree normal here. If I draw it here at the edge, you will get this. This is basically the range of vision. Okay. Here, this is the range of vision for a convex mirror. Convex mirror has a very wider range of vision. If you talk about plane mirror does not have a very wider range. If you draw the normal here, the vision range is the same as that of mirror. Okay. The least range of vision is of convex. If you draw the normal, this is the range of vision we have. Clear?
Yes, sir.
Why we cannot use any one of them in any of the example? The reason is this only. Okay, so convex is also now clear. Now let us move to the next part. And the next part is mirror formula. You can, this is the mirror formula for all the mirrors. Okay, means this is applicable for the plane mirror also, convex mirror also, concave mirror also. Any of the random position of the object you can take. You are independent, and this is the mirror formula. It is applicable in all the mirrors. Okay, not in a special case. So we take any of the possible location from 1 to 6. Suppose I'm taking location number 2, or any of the location you tell me, I'll take that, because location number 2 has little complex things. So we can easily location number 2 or location number 4. They have little complex things, so that variety will be explained in that case. Okay, so I'm taking location number 2. Location number 2 is at infinity after beyond C. Okay. Let us complete the diagram. We will do the smart work. Labor is more effort, more labor is not required. This is physics. You cannot learn the things. You have to do a smart work. So let me have a object. This is infinity, we very well know. I'm not drawing that. This is C point. This is F point. This is the incident ray. The rays are not perfectly drawn, don't no issue. Then it will cut to the focus. Again, now don't think Don't think that they are cutting each other. No, this is the incident ray 2. This is the reflected ray 1 dash. They cannot intersect. Okay. So this is point P pole, and we have another. But you tell me where is the image found before drawing this? Let us do the smart work which I was talking about. This is the situation.
Sir, before the real.
Hmm? Clear? This is the image, real, diminished. We very well know first. You know? If we know the location of the object, we know the location of the image. Now we will join the lines. Let us join the line from this point, parallel. Okay, again from this point, I will join this point. Okay. Now this is the point. Wherever it intersects, I will say this is the point focus. Okay. Don't take tension. This is the ray going. Okay. Now again taking point, joining with pole, again taking the line such that the line should pass through this. Is it clear? See how smartly we have done. So this kind of smartness is required. 1 dash, 2 dash. Okay. Now we will again try to find out the terms. You are very much familiar with the word U, V, F. Please tell me what are they?
Sir, U is a distance of object, V is a distance of image, and
Distance
F is a
object
focus.
from where?
Sir, object from
Mirror, right? All the calculations, all the distance measurement, everything are done from the reference of mirror. That's it. What is our reference? Our reference is mirror. That is why I'm writing from mirror. Focal length is again a distance only. Distance of focus from mirror. That's it. We have the three terms. So we needed these terms in our triangle as well. This is the pole. Can you see the triangle? Let me give the name as well. This is A. This is B. This is A dash. This is B dash. So we can see the triangle A, B, P, and triangle A dash, B dash, P. They both are similar. Let me draw it separately. Big triangle and the small triangle with the same point P. This is A, B, A dash, B dash. This angle will be equal to this angle because it follows the law of reflection. Is it clear? And these two angles are 90 degree.
Yes, sir.
So the two angles are equal, they both are similar. So if they are similar, then A, B upon A dash, B dash. Why we are taking? Because we needed the ratios of the image and object. So that is why I have written in this way. Or you can write A dash, B dash upon AB. You are independent to write any of the term. So A dash, B dash means a smaller triangle in numerator, bigger triangle in denominator. So this you will follow the symmetry. One side you have taken this. Now another side I'm taking this. Why I'm taking this? Because we know AP is the value of U. Yes or no? Right? And A dash P is the value of V. Let me trace it here. This is U. from the pole, and this is V from the pole, and this is F from the focus and pole. All the measurements are always done from the pole only. Okay, so this triangle is similar. A dash B dash is A dash B dash upon AB is equal to A dash B upon AP. Clear? Equation number 1, because one triangle is done. Now we have another triangle, and we can see that this ray is parallel to principal axis. Tell me, is this ray parallel to principal axis?
Yes, sir.
If yes, then this size will be same because they both are parallel lines. So this will be AB only. This will be AB only, right?
Yes, sir.
So this is point B, this is point A. A is very close to P, we assume this. Okay. So we have the new two triangles, that is B dash, A dash, F. A and P are same point, and B. Clear? So can you see the similarity in this triangle, as these two angles are 90 degree and these two angles are vertically opposite angles, because this is one principal axis, one is, both are straight lines, so vertical opposite angles. So they both are similar. Again, I will write in the same pattern this way only, and that is A dash, because I needed to equalize both the equations. This upon this is equal to this upon this. So A dash F upon PF you can say, or AF, both you can say. Okay. Now can you see one interesting thing, bacho? That is A dash F is the value, A dash F is the value of V minus F. Is it? Because this is entire V and this is F. Clear? So we have equation 1. On solving, we will get A dash B dash upon AB is equal to V upon U. A dash P. A dash P, search it out. A dash P is the value of V. AP is the value of U. Similarly, here we have A dash F is the value of V minus F upon A dash F or A dash P. The same value only, that is focus, focal length. So that you will write F. Now equation number 1 and equation number 2 are same only, we very well know. So I can write equation 1 is equal to equation 2. So I can write this pattern as V upon U is equal to V minus F upon this F. Okay. Now cross multiply the terms. What you are getting is VF is equal to UV minus UF. Now you can see we have three values UVF. Okay. And in this equation, we are seeing individual part has two values, and all two values differ, UV, VF, UF, like that. So for the convenience to shorter the term mathematically, what we do is dividing equation both side from UVF. What we get? VF upon UVF is equal to UV upon UVF minus UF upon UVF. What we get is 1 upon U is equal to 1 upon F minus 1 upon V. So what ultimately I am getting is 1 upon F is equal to 1 upon V plus 1 upon U. Okay. So this is what the mirror formula you are getting. Is it clear to everybody?
Yes.
Great. So this is what we are done. Now we will talk about the next term. And the next term is magnification. And then we will move towards the sign convention. A very easy trick I'll tell you to identify the plus minus terms. And then I'll tell you the pattern to solve the questions. Okay, what do you understand by the word magnification? What do you know about the word magnification? What is this magnification is? Magnification means how magnification is actually the comparison. As the word magnification comes, generally students think a large image. No, this is not like that. Magnification simply means the comparison of image from the object, not from any other thing. Simply the comparison of image from the object, whether the image is smaller or larger, that is what the comparison we are talking about. So it is simply a comparison. So for comparison, what we use generally in mathematics, we use the ratios. So we will use the ratio to compare these two terminology. So we use, if I talk about the same situation, you can see AB and A dash B dash. So whatever the things we want to compare, that is A dash B dash, and from the reference to which we compare, always write in denominator, that is the object. So I can even write this I. Capital I means size of image, capital O means size of object. In your books you will see that it is a height of image upon height of object. Generally students used to forget which is to be written in numerator and denominator. So for that simplification, this is my pattern of writing I upon O. I will always be in numerator and this always in denominator, which tells you about the M. M is the magnification. Okay, is it clear? Is it clear to everyone?
Yes.
Now, as you can see, this is A dash, B dash upon AB is V upon U, right? So it means V upon U is also one of the pattern to detect you the magnification. But I'll not go too longer. I'll just tell you in briefing what is magnification formula you're going to use. I upon O minus V upon U. How this came? This came by applying the similarity, the triangle, the comparison, and then you will get to conclude this. This is one formula, this is one formula we generally use for the numerical part. Now we are going to talk about sign convention. Always remember, bachcho, this is for mirror. In mirror, mirror formula is having positive, and just opposite to positive is the negative value, which will be for the magnification. And if you talk about the lens, the situation will be inverted, that in lens formula 1 upon V minus 1 upon U will be in the terms of formula, and the magnification will be plus V upon U. Okay, inverted things will be there. Always remember that. Okay, now sign convention is our next heading. sign convention. If we talk about sign convention, so we are going to use the signs. How? Let us see. Do you know Cartesian coordinate system? As you all are the mathematics students, we are very much familiar with this term. Linear equation, no? Two equations, intersection point, many of the things we have studied in mathematics. So ultimately, you will very well know about the Cartesian coordinate system. What is this point known? The origin. Okay. If from the origin you are moving in this direction, what does it mean? You are approaching the value, the increasing value in positive, +1, +2, +3. On the same way, this will be considered negative if you move this way. On the same way, upward positive and downward negative. Yes or no? We are going to use the same here as well. Suppose you are taking a concave mirror. This is the concave mirror. Principal axis, center of curvature, focus. Now, bacho, here we have origin O. Origin is the reference from where all the calculations are done. Point of reference, frame of reference. So here is the pole. Pole is considered as to be the reference in the entire situation. This is the pole and pole is the reference. Suppose the object is placed here. It means if you wanted to catch the object, you have to measure from the pole and you have to move this way, right? So -1, -2, -3 like that. Ultimately minus u will be the sign convention. Okay. Now on the same ground, if you wanted to measure the focal length, so you have to move towards focus. So in this direction you have to move, right? Again, suppose the object is here, so u will be negative because from the pole you have to move this way. Is it or not? So if you have to move in this direction, it would be negative. If you wanted to measure focal length, it would be negative. But suppose if your object is at this location, so and your image is virtually here, so for measuring the V, you have to move this way. V will be positive. Is it clear? Yes or no?
Yes.
Okay. If this is a convex mirror, you will say, sir, u will be always negative because from the pole I have to move this way, and a focus will always be positive for a convex mirror. Say yes or no. Focal length, and V will be formed here virtually, so V will always be positive. You will say this, na? For a convex mirror, yes or no? And you will use this same pattern. Speak up fast, then I'll tell you an interesting thing.
Yes.
Try to mug up the things, bacho. Now, if I take this same convex mirror, but I have inverted, is it possible to keep the convex mirror this way and you are visualizing yourself? Is it possible to invert it this way and my face is this side towards the reflecting surface? Yes, it is possible. I can invert. You are seeing your face on a handy type of plane mirror and you can tilt anywhere. So I have given you this situation. The situation is here. In this case, what you will do? Now see from the pole, you will place an object in front of a reflecting surface only. So you will put the object here. Now here u will be positive. Yes or no? And focal length will be negative and the image formed will be negative. Is it clear? So we are not stuck. We will not remember. We will not mug up the things. We will draw the situation. Drawing the situation is very essential, very much required. If you really wanted to solve any numerical, you have to draw the diagram of the given situation. Then only the teacher will understand, yes, you have not done the things you have actually solved. Okay. Now, I think the sign convention is clear to everybody.
Yes, sir.
Yeah.
Very nice. In the same way, concave mirror can also be placed this way. This is also concave mirror. Object will be placed here. Focus will be here. Center of curvature will be here. Yes or no?
Yes.
So what will happen? Image will be formed here. This is location number 4. 4 dash. Remember? Between C and F. You can place it anywhere. Okay. So U will be positive. F will be positive. V will be positive. All are positive. Here, minus U, minus focal length. Suppose this is the, sorry, this is the another case. If the object is here, then if the real images are there, 1 to 5, 1 to 5 point, all the values either to be totally negative, totally to be positive, depending on the given situation. You should remember the diagram, the pattern of drawing. I have told you the trick. This is my trick which I told you, and from that you can easily detect the diagram and you can easily trace the sign convention. Okay, now let us do one of the numerical. Are you all ready with your pen and paper? I'm going to speak a question and you all have to simply you have to write the question to solve the question. Okay, shall I repeat the question? Shall I start the question?
Yes.
Are you all ready? Okay, now I'm speaking, just write it down. An object is placed in front of a concave mirror. An object is placed 60 centimeter in front of a concave mirror, 60 centimeter. An object is placed 60 centimeter in front of a concave mirror. Of focal length 20 centimeter. An object is placed 60 centimeter 60 centimeter in front of a concave mirror of focal length 20 centimeter, of focal length 20 centimeter, focal length 20 centimeter, if object size is 5 centimeter, if object size is 5 centimeter, find the location and size of the image. If object size is 5 centimeter, find out the location and size of image. I hope the question is clear to all of you. Now try to see how much dimension, 60 centimeter, 30, 20, what the values are given. From those values, you have to see from the trick 1 to 5, 1 to 6, what point number is allocated for that question. So object is placed at 60 centimeters.
Minus 30 centimeter.
Minus 30 centimeter. Very good. Yes, calculated the terms. Minus 30 centimeter. What you are telling, beta?
Sir, position of
Before taking your pen in your hand, try to see the things. This is the pole, bacho. This is the focus. Focal length is given to you is 20 centimeter. I'm not writing minus plus, that is only being used in sign convention. Center of curvature and the radius of curvature would be 40 centimeter. Is it clear? Now the object is placed at 60. It means the object is placed at beyond C, 2 number. So the image will be diminished. And it will be here between C and F. We are already known. This is 2 dash, right? We are already known. We will trace everything. We will get the value. So U is given to us. Now we know that this is this point is at 40. This point is at 20 measurement. So the value of V should be less than 40 and greater than 20. Is it clear? This is without touching the pen. You can just take an idea. So what the value should come. Is it clear to everybody? This is the pattern of understanding. This is the pattern of doing and smart work. Now you will start solving the terms, and students, just tell me what I was talking about. Magnification. Magnification is I upon O. Where object is greater, we very well know, and image is diminished. So the magnification should be more than 1 or less than 1.
It's -1 centimeter.
No, -1. How is it possible? Minus
Sir,
1 means, leave minus. Simply 1 means I upon O is equal. I is also equal to O, which is not possible. My magnification should be less than 1 because the image is diminished. If it is the same size, the magnification will be 1. If the image is larger than the object, then the magnification will be more than 1. Is it clear?
yes.
I will write the term as well. Don't worry. This is one thing. Another thing, if my magnification is plus, it means my image is this way, because this, if this is plus, then the value will be in plus, which means this is not, this is plus y, in plus y direction. But as we can see, the image is in minus y axis direction. So the answer should come in negative, and if the negative answer is coming, it means the image is inverted. Okay, so it means it will be a real image because real lines are intersecting. It is the case of 1 to 5 object locations. So 30 centimeter minus 30 centimeter means from the pole you have not to move this way, because it is positive direction. You have to move this way in negative direction till 30, and then you will get the V. Is it clear? Now let me tell you the steps to solve any of the question. The first step is to draw the diagram. Draw the diagram as per given situation in question. After drawing this, step 2 is mirror formula. After this step, the third condition is apply sign convention. You will use these steps in every question. Now, when you will apply the sign convention, what is unknown, you needed to find it out. You very well know that V is unknown. So the term which is unknown, we will not use the sign for that. Why we will not use? Because that term we needed to find it out, na? So we will not use the sign for that. We will apply the sign convention only on the given quantities, but we very well know the value of V should come negative, because we have the picture of the diagram in my mind and in front of us. So 1 upon minus F, sign convention applied, is equal to 1 upon V. I will not write positive, negative, nothing, neutral, because it is unknown quantity. Plus 1 upon minus u. Is it clear? So ultimately what we have, 1 upon v is equal to 1 upon u minus 1 upon f. Sign convention done. Now the fourth step is, and simply in fourth step, now you will not do any plus minus nothing. Simply write the value. Putting the given values. 1 upon, what is the value of u? 60 minus 1 upon 20. 1 upon v. You will get the answer. Now, from here only you can see 1 upon 60 is smaller because denominator is big. This is greater. So the answer will be coming in negative only. Okay. 61 minus 3. 1 upon v. So v is equal to minus of 60 upon 2. Minus of 30 centimeter is our answer. Is it clear? Now the next part, if we talk about the next part, in the next part we are going to see that magnification, I upon O. I is in negative, we know, predefined. This is positive, so our magnification should come negative. Okay. And the another formula is minus of v upon u. This is simply the formula I've written. Either we will use this part or we will use this and this. Okay. Together we do not use. This is the mathematical term. Okay. M is equal to minus v upon u, simply formula. Now sign convention, M is equal to step 1 formula, step 2 sign convention. Minus is as it is because it is related to formula, minus v sign convention minus u sign convention. 2 minus are cancelled out, 1 minus remained, and v is how much? 30, u is 60, minus of 1 upon 2 less than 1, minus of 0.5. Is it clear? And magnification does not have any unit because you can see v and u have same unit, cancelled out. Okay, magnification we have got. Now magnification is equal to I upon O, where M is equal to I, we don't know. O value is a positive of 5 because it is erect this way. Object. Okay. Magnification is minus 1 upon 2. I upon 5. So I is equal to minus of 2.5 on solving you will get in centimeter. Why in centimeter? Because this is in centimeter. So this is what ultimately you are getting, a diminished and inverted image, half of the size of the object. Is it clear to everybody?
Sir, that last formula which was applied by you, that is for height of the object.
Yes, beta. I means height of the image, height of the object. Okay.
Yes.
Okay. So magnification 1, magnification less than 1, magnification more than 1. Magnification is 0. It means point size image. Okay. 1, then same size, then enlarge. This is one. Another thing is magnification positive, image is erect, magnification is negative. I hope from seeing the magnification term only you can judge the things. Is it clear? So this all you all have to remember. Is it clear? Have you all noted?
Yes.
Yes.
Wonderful. Okay, so write down next question. An object is placed (20 cm) in front of a I'm repeating the question. An object 10 centimeter, an object 10 centimeter, only 10 you have to write, all the terms will be same, written statement. An object 10 centimeter is placed in front of a concave mirror an
Can you
object 10 centimeter is placed (20 centimeter) in front of a concave mirror. An object 10 centimeter is placed 20 centimeter in front of a concave mirror of focal length 40 centimeter, of focal length 40 centimeter, of focal length 40 centimeter, find out the size of find out the size of image formed.
Sir, 10 centimeter.